This is your Physics 42 Capacitance Lab. What you're looking at right now is the front page of the handout that's available on the Canvas page. If I scan back here, you'll see some connecting wires. You'll see a multimeter here on the right, and then you'll see a blue cylindrical device. That's one of the two capacitors that you'll be using. The quantity that you're going to be measuring in this is just the capacitance. So we'll have a capacitance meter. And you're also going to be measuring potential or voltage, and that's where this device comes in. This is what's called a multimeter, and you'll notice that there's several settings. For DC current, or for DC circuits, direct current, that means the current flows just in one direction. So if you need to measure potential, you'll set it to here. That's DC volts. Down here, this is DC amps for current. And then if necessary, you can measure the resistance of a device, which we're not going to do today. In order to measure the capacitance, we have a special meter up here in the front of the lab, and one of the other capacitors is already hooked up to it. And I can simply press this button. It sends a signal to the capacitor, and then looks at how it discharges, and then from that calculates what the capacitance is, and you'll notice that it's roughly 1480 microfarads, and so that's about 1.48 millifarads. And I release it, and then I can switch this out and measure the other capacitor. And what I can assume is that once I have those values, they will remain fixed throughout the entire lab. One thing you'll notice about these capacitors is, if I come down here, if you look at the two leads, the lead on the left has a small plus symbol. That means that the high potential should always be connected to that lead and not the other. These are what are called electrolytic capacitors. They're built in such a way so that they're polarized, but what's nice is that they're very stable. They tend to have fairly high capacitances, and their capacitances tend to be very stable. Okay, so the first thing we have to do is set up our power supply. So if we come to the front of the table, we've got our control unit down here. The two ports that we're going to be using are on the right. They're colored red and black. This is the high potential, this is the low potential, and then we can control it with this knob. When the knob is turned fully counterclockwise, it's 0 volts, and when it's fully clockwise, it's roughly 25 or 30 volts. So we have a pretty large range. For this lab, we're going to set it to about 10. So the first thing I have to do is bring my multimeter over, set my multimeter to DC volts, let it turn on. Right now I've got no potential, so I'll take the high potential lead here and I'll plug it into the high potential coming out of the power supply. Then I do the same thing right here, come up and take a look at my value, and I've got about 10.20 volts. And you'll notice that's nice and steady. Doesn't have to be exactly 10 volts. You want to get as close to that as possible. And then you can assume the value is fixed. You can measuring potential is pretty easy because you just have to probe across the 2 points in space that you're looking at. And so you're always free to come back and measure this to make sure it's steady. But what you'll find is that these units in the tables are very steady. So we'll assume our voltage is 10.2 volts to 3 significant figures. Okay, so the first thing I have to do is hook up the power supply to one of the capacitors. So I called this capacitor C1. I have to note where my plus symbol is. And so if I pull it out, I'll notice that it's the one closest to my thumb. So the high potential will go in there. So what I'll do is I'll remove my multimeter, put that out of the way for right now. Grab 2 more wires. And begin hooking it up. So that will go in this one, the front one here, the one that was closest to my thumb. And I'll take another lead right here, and that will go in the other port right here. Okay, so it only takes probably a few microseconds or a few milliseconds to charge it. So I'll pause right now, and then we'll hook up the voltmeter. Okay, so now you're looking at it from above. You'll see the voltmeter is just fluctuating because the 2 leads from the voltmeter haven't been hooked up to anything. So what I'll do is I'll simply hook them up to the proper plates of the capacitor, and you notice I get about 10.2 volts. It's a little bit higher than that, so most likely the power supply fluctuated a little bit. So what you would want to do is go back to the power supply, measure the voltage again, make sure it's steady, and then come back and measure the voltage across the plates of the capacitor and verify that they're the same. Okay, when I take it off, the reading goes out. So now what I'll do is I'll disconnect the capacitor from the power supply, and then I'll hook it up to the other capacitor. So let me pause. Okay, the other capacitor is in place. Again, the plus symbol's right here. So what I'll do is I'll take the positive lead out of the power supply. Remember, that's hooked up to the positive lead over here, and I'm going to connect that to the positive lead of this new capacitor. And I'll do the same thing here. And now what I'll do is I'll measure the voltage across each. So you can see my voltmeters there. Bring this over. I get a reading of 6.67. And when I do the same thing over here, I get a reading of 6.68 or 6.67. Okay, so that shows conservation of energy. So this one right here lost some potential. So that means it lost some charge. So that charge obviously was delivered to the plates of this other one. Everything comes to equilibrium when the two potentials are identical and there's no more energy able to drive more charge onto either plate. Okay, then you'll record those values, go through the calculation, and just verify that the charge is conserved. Then what you'll do is pull these apart. And you want to discharge a capacitor because it's like a coiled spring. You don't want it to let loose when you're not suspecting it. So I'll just use the pair of scissors here. You'll see sometimes a little spark coming out. You might hear a little snap. So now they're both grounded. In part 2, you're doing the exact same thing, but you'll charge this one, then disconnect it from the power supply, and then deliver charge to this one. Okay? Then in part 3, you'll hook them up in series. So here, the high potential end is this one right here. And for this one, it's this one right here. So in that case, what I'll do is I'll come out of my power supply. I'll put it into the high potential end here. Then I'll come out of the capacitor and go into the high potential end of this one. And then I'll go from the other plate of that capacitor back into the power supply. So now you have two capacitors, C1 and C2, hooked in series. And what I can do is measure the capacitance. So for the first one, I get 3.7 volts. And for the second one, I get 6.46. Now that should make sense. This taller one has a larger capacitance. It has a larger capacitance than this one. Remember, in series, the charge that's driven off the plates of this one ends up on this one. So the Q values for these two have to be the same. But since this has a smaller capacitance, for the same Q, it has a larger voltage. And so when I measure it, I get almost 6.5 as compared to this. So it matches what we talked about in class. Okay. Just follow the directions. When you're done, disconnect everything. And again, you want to discharge them for safety. So I'll bring in the pair of scissors, and then I'll simply cross the plates and discharge them. And then in part 4, you'll simply hook them up in parallel. So in that case, what I'll have is coming out of the high potential end. I go into the high potential end here. But now I have to split the current. So some of the current's going to go into the first capacitor. The rest of it has got to go into the second capacitor. So I'll split the current right here. And I go into here. So as the current comes in, move the camera here. As the current comes in from the power supply, that's this wire, this wire, some of it will go up this wire and into the second capacitor. The rest will go down here. When I come out of this capacitor, I want to go back into this capacitor, and then this one will rejoin and go back to the power supply. Okay, so the parallel arrangement looks like this. I come out of the power supply, and you'll notice I have my nodes. That's where the current splits. My current splits here, goes into both capacitors, then that recombines here and goes back into the power supply. So that's my parallel arrangement. So that tells me that the voltage across this and the voltage across this should be the same, which should be the same as the power supply, which is roughly that 10.2 volts. So let's just verify that. So the larger capacitors right here, I measure the voltage, I get 10.2, and I do the same thing down here, and I get 10.2, verifying that they're in parallel. Okay, follow the directions, you go through, you'll get your values of the charge, and test energy conservation, and then in part 4, you're going to do something slightly different. Okay, so once you do the parallel arrangement in part 4, now what you want to do is look at charge recombination. So again, what I'll do is I'll remove everything from the power supply. I'll be careful not to touch the plates. Like this. Now what I want to do is I want to hook them not similar plate to similar plate, but opposite plates. So the positive poles are right here for this one where my thumb is, and right here for this one. So what I'll do is I'll bring in a switch. I'll put the switch right here, and I'll open it. Okay. And what I'll do is I'll go from the positive plate into the switch. And I'll go from the negative plate to the positive plate of this one. And I'll go from here into the switch. So right now nothing's transferred. Once I close the switch, I've had some transfer. So now if I come in, I can measure the potential. So it looks like I have, what is that, about almost 3.1 volts here. And I've got about 3.1 volts here. It's negative because I have the leads flipped, so I'll simply flip it around like that. Okay, and since there's some charge recombination, when you do your calculations for charge, it's going to look like a lot of it has disappeared, and you have to test how much has disappeared. The charge recombines basically in the wires, and that energy is given off as heat, which is something in this case we can't measure. But you should notice a distinct or significant amount of charge recombination.